So hello everyone, my name is Scott Murray and this presentation is Evolving Vehicle Signal Specification Usage in AGL. A little bit about myself, been a Linux user since the early 90s pretty much, about as early as I could use it. I've been doing embedded Linux since 2000. I've worked for Konsulko Group since 2014. Konsulko is a embedded Linux consulting firm, and we've had a contract to do stuff for AGL since 2016. Actually, it's maybe 2015. I've worked on it since 2016. I've done a lot of Yocto project maintenance work for AGL, as well as demo development, a lot of integration work and maintenance. One of the things that I have done a lot of in the last few years is basically like the CES and Embedded World demos, helping put those together. So this talk, I'm looking to cover just what is the Vehicle Signal Specification, what we call VSS, the Vehicle Information Server Service, which is a bit of a mouthful, KUKSA.val, and what KUKSA.val and VSS usage in AGL looks like, and how it's changed over the last year or two, and then go on a bit into the future development plans. A little bit of a caveat, if you attended the AMM in Berlin, some of this content's going to be somewhat similar in the start of it, and at EOSS a couple weeks ago I gave a lightning talk about some of the changes in this space around the VSS, and so there'll be a bit of duplication here, but there is some updates around the future planning. A few things have shifted schedule-wise, and there's some new thoughts that I've had in the last couple weeks. So I'll try and be quick on the overview stuff since it has been covered in previous presentations, but Vehicle Signal Specification, VSS, is an open source project that came out of KUKSA, and it's a major part of their SDV sort of work, this CVII project that they're doing with the W3C. And so it's, BMW and Bosch and Volvo, I think Volkswagen's been involved at various times, and some other smaller companies. And what made it interesting to myself, and when I pointed out to Walt and Jens Simone and other folks, is that there are standardization projects around aspects of VSS under the W3C, which means it's not just a KUKSA project, it's a bigger industry-wide thing, and there's signs of it being picked up and used by multiple companies. So what is it actually? So there's a hierarchical signal schema. So here's an example here is, you have a vehicle at the top level and then powertrain, combustion engine, speed. One of the other things you'll see is vehicle.cabin, and then there'll be like HVAC or infotainment, and then, down the tree. It's typically stored in JSON format. Other formats are also possible, and it's actually being generated from a higher level set of metadata, which are called VSpec files, which I'll show an example here in a minute. There's metadata tools called VSS tools that are also open source. This is all open source stuff, that where basically you can take the VSpec files and generate the output format that you want, whether it's JSON, or I think DDS, or there's a few other things as well. Right now, the project has gotten in the last, I guess, 2.5 years, gone from basically version 1.0 to 4.0, which is basically open source contributions coming in from OEMs and other companies, basically refining the signal set, adding things they think are missing, and features as well. So a major recent change in 4.0 in VSS was the addition of structured data types as signal values, which I'll talk a little bit more about later. And so there's sort of an evolutionary process going on, and it's very interesting. It's up in GitHub. You can make a change and submit a pull request. It's a very typical open source project. So here's an example of a VSpec. So it's actually pretty much a YAML file, VSpec. This is just an excerpt, the vehicle hierarchy here. You'll see the URL of down into the repo. There's a bunch of VSpec files, and the tooling sort of glues the tree together out of them. And here's what the JSON that comes out looks like, which is, not a big surprise. It has basically the same values. And so what do we do with this stuff once we have it? So the sort of next component in this, sort of system is, the vehicle information service. So there's also a specification that's, been developed as like a parallel project, also open source, same companies pretty much. And it's actually a little more concretely being standardized with the W3C. There's a couple of clear specifications around the API and the transport stuff for VIS. So there's actually multiple things in the specification. There's HTTP, sort of URI, sort of API, like sort of RESTful, WebSocket, and MQTT. And so basically these APIs allow you to access a server that's implementing a VSS database, and so you can do the typical sort of get, set, subscribe type of operations for vehicle signals. There's a reference implementation of the server in Go, which is up on GitHub. It's at this point not particularly heavily maintained. The V2 spec is pretty stable and isn't changing dramatically. And as well, there's a partial implementation of VIS in C++ in a project called KUKSA.val. And so for us, the C++ version was a little more interesting, and Bosch were more active in developing it. So it's also, completely open source. It's now under the aegis of Eclipse. And it's, as I said, developed by Bosch. There are other companies making contributions to it as well. And so the interesting thing about KUKSA.val is it implements most of the vehicle information service spec V1 and some of V2. There's a whole bunch of filtering options that were added in V2 that are quite complicated to implement, and Bosch pretty much decided not to do that. And when you get down to it for relatively straightforward vehicle signaling things, you don't need a lot of that functionality, so you can get away without implementing a lot of it. So basically the original server is a C++ project, but as well they did a second implementation in Rust that extends the API with basically a gRPC version. So protobufs with gRPC, basically very similar to the VIS API, but completely binary and strong data types. And so that's actually implemented what's called the KUKSA.val databroker, which I will talk about quite a bit more as we go along. They also have implemented a JSON web token based authorization mechanism. There's Python and Go client libraries in the KUKSA.val repo with example applications that use them. And also example what are called feeder clients that are written with the Python library that are used to push data into the server. So basically that's how you sort of get a full system is with the KUKSA.val model. You have a feeder that's for say reading CAN and pushing it into the server. So the C++ server that was the original implementation provides a mechanism for modifying or adding new signals via overlay JSON files. So we were using this initially in AGL for some things. The data broker does not do the same thing. It doesn't have its own overlay scheme like that. And so overlays are actually done using VSpec files. So they sort of YAML looking stuff that I showed to begin with. And you basically generate a full VSS tree with your overlay integrated. And that's currently being used in our AGL demos for the steering wheel switches for our full demo setup. and some other signals around navigation. And so that's actually in tree. There's a VSpec file. This path into Medi AGL demo shows it. And here's an example. So if you think back, the vehicle speed YAML of the base VSpec, what this does is basically providing enough data that the tooling can basically put this DBC field on top of that plain signal definition and add in this extra metadata. And so the PT vehicle average speed is actually the name of the CAN signal out of the DBC file that will be mapped onto the vehicle speed. And the interval is how often it should accept updates. And so that's actually a full link there into the tree. I'm going to go somewhat quickly because I only have half an hour. And so I mentioned the feeders. So in addition to the CAN feeder, which is called the DBC feeder because it uses CAN database files from the vector sort of CAN tooling, the KUKSA.val feeder repo also has a GPS feeder that can basically push in data from GPSD. I believe it also has the ability to push in a CAN data set to sort of simulate GPS positioning. There's also a replay feeder where you can actually sort of record signal values out of KUKSA.val and then play them back later to actually kind of recreate a set of events. Right now in our tree, I actually build the DBC feeder. So far, no one's really pushed us to do anything with the other feeders, but it would be pretty straightforward to build them if you needed them. All right, so that's the high level, is VSS, VIS, and KUKSA.val. So exactly how am I putting all this together in AGL, and what's changed in the last year and a half or so? So originally we added KUKSA.val, the original C++ server in the Marlin release. So that was last January-ish timeframe. It's a replacement for what had been the old app framework, the AGL service CAN low level, the signal composer. And when we took that stuff out, we needed a replacement because we weren't going to have any vehicle signal support. And so the timing was good that VSS and KUKSA.val were getting a little bit of press at the time and were visible, and it was noticeable that they weren't just a Cobisa thing. There's other wider industry interest in them. And so it seemed worthwhile to pick them up and try using them in AGL to expose AGL members to these new things. So I wrote some recipes to build the different pieces, and those have evolved over time. Those are in Meta AGL demo at the moment. And like I mentioned, we now have some recipes around the tooling to generate custom VSS trees, basically, around VSpecs files. And the DBC feeder is built and packaged into images in the demos. And so as mentioned there's a very minimal virtual car DBC file that I basically translated out of the old application framework configuration. It really only has a very minimal signal set. If someone wants to contribute a better CAN definition, please let us know. So that was Marlin. That's basically last January, beginning of the year. We did ship that in spring. And so that was KUKSA 0.2.1. At that point, the VSS spec was sort of at 2.2 was their version number. And like I said, that was originally the C++ server and using the WebSocket API, the VIS, and the DBC feeder. In the summer, the Nifty Needlefish release, we just basically bumped up to newer versions of KUKSA.val 0.2.5, and that got us to VSS 3.0. And then basically this past spring with Octopus, we kind of went to the next big major release of KUKSA.val, which is 0.3.1. That got us to VSS 3.1.1, which for the most part was bug fixes in VSS. There wasn't major changes, I don't think. And at that point, we had to switch to using the VSpec overlay. which is somewhat tied to the data broker, but it's complicated. So the upcoming Pike release, 16.0, at the moment we're still going to be using KUKSA.val 0.3.1, but there are some updates. I have bumped the commit level of KUKSA.val to pick up some data broker fixes. As Walt mentioned in his AGL sort of roadmap stuff, the data broker is in images now, the demo platform images, mostly for evaluation and testing. The C++ server is still what's in there and being used by the apps. But we have a benefit of, if the data broker is in the image, it's actually testing the Rust mixin layer that makes sure we can actually build, Rust 1.68 binaries across all our test platforms, because, that was something we hadn't tried to do before. And it gives me something to work against because I'm doing the conversion of apps, which I'll go into a little more detail on. But so the goal had been for Pike to actually get the apps all converted to using the gRPC API against the data broker, and we would just drop the C++ older server. And so that's not going to get done. I got somewhat far along, but between travel and just, bug fixes for Pike, it kind of slipped on us. So I will elaborate further. There's still hope of getting it into Pike, but just not for the 16.0.0. So, what are the applications that are using it and how? Because, this is the work. It's like the server is one thing, but then we have our client side. So there are two categories of applications that interact with, VSS. They're sort of like your pure observers, which are basically like, you can imagine a dashboard app is really only looking for sensor updates, your speed, RPM, those kinds of things. And so there are basically two types of signals in VSS. There's sensors and actuators. So those things are basically signing up to see sensor signal updates. There's actually what I call actors as well, which are things that actually implement an actuator. So in our demo setup, one of them would be AGL service HVAC. It's actually listening to the HVAC signals to do things, basically. In a real production vehicle, there's a good chance that's actually, an ECU somewhere is getting that actuator signal. Or there's a proxy on, infotainment board or your sort of black box, gateway that is basically seeing the KUKSA actuator signal and then converting that and driving an ECU. So we sort of are constrained to what we can sort of do in our demo setup. So we have these service daemons that sort of do some of that. One interesting thing that when you start reading some of the stuff around VSS that isn't obvious until you start playing with KUKSA.val quite a bit is they sort of extend VIS in an interesting way. And I think it'll be interesting to see if the spec in the next go around of updates changes somewhat, but they extend the concept of setting a signal to say, well, an actuator has a target value and a sort of like current value, basically. It's actually got a split. And so the ideal model is you basically set an actuator to a target value, which in the KUKSA.val implementation, they have that as a thing. And then when the actuator actually takes effect, it sets the current value, basically, so that an application could see that the change has taken effect. And so this isn't a hard requirement to use KUKSA.val, but they do sort of assume that you're going to do that when you're using the data broker. It's sort of more implicit with the way the protocol works with the gRPC API. So it's something to keep in mind if you start playing with KUKSA.val. So I mentioned AGL service HVAC. Originally, with the old app framework, it sort of basically had a whole API of our own sort of design. That code, basically, I reworked it quite a bit, and now basically it subscribes to a handful of the VSS HVAC signals and pushes those out. In our full demo setup with the green machine that you may have seen, there's basically a little HVAC controller. So the daemon actually pushes out CAN messages to set the speeds, as well as writes some GPIO settings to actually change the LEDs. The other app in this space is the audio mixer. There's a service daemon for it. It also used to have its own API with the old app framework, which basically was sort of mapping onto WirePlumber, so to provide an abstraction for apps. Now, basically, it's sort of been greatly simplified. There is a VSS signal that's sort of like a main, like master volume control. And so basically, we're pushing, like controlling volume down with the VSS signal. At the moment, the VSS hierarchy doesn't have anything finer grained than that. So we may end up circling back around and doing like a more detailed, like, AGL, gRPC API to show like mixing behavior. But that's sort of a little bit out of the scope of VSS at the moment. You might have seen our Qt and Flutter demos. So basically, in both of them, they have a suite of apps that have actually been changed to actually use VSS signals. So the home screen, it's like the volume control. The dashboard and cluster dashboard, it's the speeds and things like that. The HVAC is what I said, when you actually change those temperatures, it's going and changing a VSS signal, and then the AGL service HVAC is seeing the change. In the Qt demo, the navigation actually is going through VSS. There's a series of navigation signals in there. For the Qt demo apps, the WebSocket code that's currently being used is all sort of abstracted into a library that we use called libqt app framework. There's a vehicle signals shared library out of that tree that basically has all that code, so the apps aren't duplicating it so much. The Flutter demo is very similar. It pretty much has the same set of apps with the same set of signals. There's a few more things wired up in some of the apps, but there isn't a Flutter nav app today, so it basically doesn't exercise that stuff. One drawback with the way the Flutter code is right now, all that WebSocket code is sort of duplicated amongst those apps. We haven't had a chance to kind of try to pull out a library, but we might not do that anyways because we're going to change things around to use gRPC instead. So that gets me to our future development. Not doing too bad for time. So I'll kind of go run through the big categories again. So VSS, is we're consuming it, of course. So VSS 4.0 was released in late May. It does have some impact that would actually affect some of our demo stuff. The big one is that they switched from left to right as positions in the car to driver passenger. That was sort of advocated in the VSS community by a couple of companies. So that's sort of been done now. The signals have been updated. And so we will have to go and do a bit of name changes in some of our demo apps to use VSS 4. The structure support I mentioned shouldn't impact us. The current upstream discussion is that they will not change any of the existing signals to use structs as return types. But they could change their minds, and then we'd have to worry about it. One benefit, it makes sense when you think about it, is KUKSA.val doesn't tie us to a specific version of VSS. You can basically configure to use whatever VSS tree you want. So currently we're using VSS 3.1.1 still, even though the KUKSA.val, they ship the JSON file that we could switch to 4.0 just by changing the command line option. So right now the plan that I have is to switch us to 4.0 for the next release, Quillback. So that'll be, end of the year timeframe. Another thing that's been discussed in upstream in the VSS community is, when you take the stock tree, it has, I think, something like 800 signals in it right now. One of the things that you can do is you can customize it. You can cut it way down. You can add your own signals. You can use a completely custom set of signals. It would be ideal if you could tell people, you can expect that your application will always see some set of signals, no matter what vehicle it runs on. And so that has come up in upstream. It's been discussed a little bit, but it hasn't gotten a lot of traction yet. But it does seem that that could become a thing down the road, because, it's to have this mechanism and not have at least some minimal set of signals that applications can expect to always be there, seems maybe we're wasting an opportunity. So I expect we'll see more discussion around this. There's also a significant discussion about expanding the scope of VSS, mostly coming from cloud integration folks. They want to, potentially expand how it's used, have more different types of metadata in the tree, multiple trees, things like that. Right now, it's not super clear whether that's going to actually affect the kind of usage we're using, like VSS 4. At least for the in-vehicle, infotainment, ECU type of stuff, it sort of seems like the active people in the community still want to keep it relatively simple. The data scientist folks have visions of doing bigger things, and we'll see what kind of evolves out of that. On to KUKSA.val. So this, like as mentioned, the C++ server has sort of been replaced with the Rust databroker, which does not implement the WebSocket API at all. It has just the gRPC API that I've mentioned. And like I said, we're building it right now, but it's not actually being used. If you check out our tree right now and build it, it just gets started and is running. So currently my plan is to get us completely switched over for Quillback, since I didn't actually get it done for Pike. But I do have visions that if, at least some of that will probably get backported to Pike for 16.0.1 or 2. And the other thing we might do is start moving some of the recipes out of meta-AGL demo to somewheres in meta-AGL, because, to try and get better adoption, it would be good if it wasn't completely tied to our demo builds. And then, people who just want to take up meta-AGL and use meta-AGL core, you could actually get the KUKSA recipes and not need to actually start picking bits out of meta-AGL demo. Another new thing is the upstream folks have written a daemon called KUKSA.vis, which is a VIS proxy for the databroker. So it sort of solves the problem that the databroker doesn't implement VIS directly. So this would give you a WebSocket API still that you could use. And so kind of hopefully ease the migration. Or if you have some set of apps that still expect the WebSocket API, you can run KUKSA.vis. So right now, my plan is to sort of write a recipe to build that and potentially use it for the Flutter applications in the short term. Another recent thing is the mock service that just in the last week or two was announced by Upstream. There's a separate services repo from the KUKSA.val folks. And that basically is actually an API that can sort of mock up a vehicle component. It's actually quite interesting. I'll skip over it a bit more, but there is some worthwhile potential there, I think, for us to do some testing with it. So if you have questions about that, come talk to me about it. On the application front, like I said, we're going to try and get the apps converted to the gRPC API. I do have the Qt demos mostly done. This morning, I sort of figured out my blocker around TLS. The Flutter is basically TBD a little bit still. So we might use KUKSA.val. The folks at Harman have mentioned that they prototyped some code, and the other option there is Toyota have shown, at least in their Flutter apps, where they basically are doing things like gRPC and Rust native code, and there's some efficiency gains there because all the like multi-threading engine stuff is outside of Dart. So we might end up there actually with maybe some help from Toyota. As well, there's some efficiency gains around the way the gRPC API works. If I refactor the apps a little bit, I'd probably be a little bit better. So that's maybe something that'll happen later in the year. Running out of time. So the other sort of open things are the authorization mechanism. This is, I've mentioned in previous talks, the JSON web tokens. In a full-blown system, you would probably have some way of controlling that, like OAuth. We haven't actually nailed down how to do a good demo of that yet, so that's another TBD. And recently, Upstream have talked about enforcing TLS for the gRPC API, and actually they're going to stop shipping any sample certificates. And it sort of raises up on us a question of, do we want to do the same and actually not ship demo certificates? Because the risk is that someone blindly takes your demo certificate and uses it in a product, and that's not a good thing because the demo certificates aren't going to be secure because they're, the keys are available. So that's the thing we'll have to sort of work out what we do. And, to sort of follow on some of what Walt said, all this stuff is not really that documented, so it needs to be followed up. So there's a couple of links here. If you grab my slides off of Sketch, basically one of the gentlemen at Bosch gave a presentation that covered a little more details of KUKSA.val and my previous AMM presentation. So I'm out of time, but if you have any questions, basically grab me at the BOF or anywhere, so I'll be here the rest of the week. So thank you very much.